All right, let's do something a little different today. Think of this as a special intelligence briefing. We're going to jump forward just a bit to get a really clear signal on the state of AI in early 2026. No fluff, just the key developments from all across the tech landscape.
And believe me, the pace of change, it's just never been faster. So, let's just dive right in.
Okay, so the first thing you really got to get your head around is this. The AI revolution, it's not something that's coming.
Nope, it's already here, like right now. And as we're going to see, it's not just happening in one place, it's advancing on all fronts, all at the same time, in the tools we use, in our jobs, and even out there in the real world.
So where do we even start? Let's begin with something we all know, something that's probably open in another tab right now, our AI assistants. Because the evolution that's happening there is just nonstop. I mean, just look at this timeline. The sheer speed is, honestly, it's staggering. We're not talking about yearly updates anymore. Just in the last couple of months, think about it. GPT-5.2 drops with way better reasoning. Then, out of nowhere, there's a health feature, which is a big deal, right? We're talking about connecting it to your medical records. And then here's the kicker, the thing that really shows you how fast this is moving. GPT-4o, a model that felt like absolute magic just a little while ago, is already being retired. This isn't just a list of features, you know? This is proof that we're on an exponential curve, where today's cutting-edge tech is tomorrow's, well, legacy software.
And these aren't just abstract updates, they change how you actually use the tool. With GPT 5.2, you now get this choice in thinking time. So you can go with the standard setting for a quick, snappy answer. But if you need something with more depth, more accuracy, you can flip on extended thinking. It might seem like a small fin, right? Just a little toggle, but it's actually a huge deal. It's a shift toward giving us, the users, more fine-grained control over how the AI behaves. You can literally dial in the type of intelligence you need for the job.
Okay, so if AI is our new daily co-pilot, well, it's also kind of becoming our new colleague, isn't it? And that brings us to a whole new set of rules for the workplace. And this isn't some theoretical what-if scenario. InfoWorld laid it out pretty bluntly. They said the time is now for businesses to start preparing for an AI agent workforce. Notice that wording. They're not talking about tools that help people do their jobs. They're talking about managing autonomous agents that, well, they do the complex jobs themselves. And a shift this big, it actually creates a whole new field. It's being called AgentOps. So if you're familiar with DevOps, which is all about automating workflows for human developers, you can think of AgentOps as the management system for this new AI workforce. It completely changes the game. Your job isn't just testing lines of code anymore, it's testing an AI's actual behavior and how it reasons. And security is not just about firewalls and pipelines, it's about protecting the AI from bad actors trying to trick it with malicious prompts. The whole goal shifts from just being efficient to achieving what they call hyper-automation, and at a scale we've just never seen before.
But this whole revolution isn't just happening inside our computers and our offices. It's spilling out into the real world. AI is learning to navigate our streets, and it's doing it by simulating reality, even the craziest, most extreme parts of it.
Just to put this in perspective, to understand what's at stake here, the Waymo driver has already driven around 200 million miles, fully autonomously, on public roads. That's an insane number. But to get to that point safely, it's had to drive billions and billions more miles in a simulated world.
And we're not talking about basic simulations. They're getting unbelievably sophisticated. For example, Waymo can now actually train its AI on how to handle driving through a tornado. I mean, think about that. That's a situation that's so rare, so dangerous, you could never, ever test it in the real world.
Or what about this? Encountering an elephant on the road. Now, this is the really cool part. This isn't some pre-programmed video game scenario. The AI is drawing on a general, broad understanding of the world to generate and then react to these long-tail events. It's stuff it has never, ever seen on a real street, but it knows what an elephant is from all the other data it's learned from. So you're probably asking, how is any of this even possible? Well, it all comes down to something called the Waymo World Model. Here's how it works. First, it starts with a foundation, something like Google's Genie 3, which is what they call a general-purpose world model. You can think of it like an AI that's watched millions of different videos to get a basic, intuitive feel for physics, how things move and interact. Then you take that general knowledge and you specialize it. You adapt it specifically for the challenges of driving. And finally, the model doesn't just generate what a camera would see. It creates this super high-fidelity data for all kinds of sensors, including LiDAR, which is the system that uses lasers to build a super accurate 3D map of everything around it.
So it's not just seeing the world, it's fundamentally understanding and recreating it.
Okay, so let's recap. We've got smarter AI assistants, we've got new AI colleagues changing our jobs, and we've got AI drivers that can handle scenarios we can't even imagine. But all of this, it brings up a really big fundamental question.
Yeah, but how does any of this actually work? I don't just mean the code, I mean mathematically. What are the core first principles that make these incredibly complex systems tick?
You know, for the longest time, building these models felt a little bit like alchemy. We had these recipes and we knew they worked, but we didn't always know why they worked so well. But now the science is finally starting to catch up. A paper that just came out last month proposes a complete mathematical formulation for large language models. It uses these really core principles from information theory and probability to build a single unified theory. Basically a set of formal laws that describe exactly how an LLM operates.
The best way to think about it is like this. For thousands of years, we all saw gravity in action, right? Apples fell from trees. But it wasn't until Newton came along with his laws that we had the actual mathematical language to understand it and engineer with it. This new framework, it's trying to do something really similar for AI. It's formally defining everything, how text gets broken down into tokens, the actual architecture that predicts the next word, how the model learns from data in the first place. We are finally moving from just building these things to developing a really deep first principles understanding of them. And that, right there, is the key to making them safer, more reliable, and, you guessed it, even more powerful.
And that brings us full circle, right back to where we began. You have our personal assistants, our workplaces, the very physical world around us. All of it is evolving at this absolutely breakneck speed. So it leaves us with one big question, right? What happens next? Seriously, what does the world even look like 6 months from now?